Hello students and friends, welcome to my YouTube channels. Today our topic is heat conduction through a hollow sphere. So today only we'll discuss the how to get the formula. So before what we discussed previous video, we discussed the Fourier law of heat conduction. What is K A dt by dx? K is thermal conductivity, A is area, temperature difference by distance. So I taken here dx for the elemental thickness. So we are getting the heat flow T1 minus T2, that is overall temperature by thermal resistance. If we did the cylinder, so area we are taking 2 pi RL. If we'll solve this, we'll integrate both sides. What we'll get? Ln R2 by R1 2 pi KL. This is the thermal resistance for the cylinder. Now we are going to take heat conduction through a hollow sphere. So here area will take 4 pi R square. What area will take here? 4 pi R square. 4 pi R square, and we'll get the formula for this hollow sphere. So here we'll start again. Q equal to minus K. What is area? 4 pi R square dt by dr, because elemental thickness is r dr, plane wall dx, so that is the difference. Now we'll write one more steps. So dr will go there. Q dr by r square is equal to minus k 4 pi dt. This will be there. Now integrating both sides. We'll integrate both sides. So what we'll write here? Integrating both sides. So Q integrate R1 to R2. Then what will be there here? dr by r square equal to minus k 4 pi then dt. What is the temperature? T1 to T2. Now we'll integrate d1 by r square dr. Now you can write this way. 1 by r square we have to integrate with respect to dr. So it will come minus 1 by r. If you integrate, this will come minus 1 by r. So we'll write directly here. Q 1 by r R1 to R2 equal to minus Ka pi then dt. So what is the temperature here? Okay, T will come T1 to T2. This will come. Now we'll solve this, or just we'll write this upper limit minus lower limit. This is minus 1 by r. So already you know, suppose AB upper limit, lower limit, AB is upper limit, A is lower limit. Suppose fx function is there na, we can write FV minus FA, upper limit minus lower limit. So similar things I am going to write here. So upper limit minus lower limit. See what we'll write here. So Q equal to minus 1 by R2. So minus 1 by R2. Minus 1 by R2. Minus plus 1 by R1. Because upper limit minus lower limit. Already one minus is there. So minus R1 over. Now this take plus K. Why? Because we'll change the temperature. Actually what we'll write? Okay, one more time we'll write this. Minus K 4 pi. Minus K here 4 pi. So minus K 4 pi. Then T2 minus T1. Now we'll write T1 minus T2 to the minus will go. So here also we'll arrange Q. What we'll write? 1 by R1. Write plus first. Minus 1 by R2. Then here also T1 minus T2. So now write 4 K pi. Just nice to look. It looks nice. 4 K pi. T1 minus T2. T1 minus T2, we are getting this. Now we'll write what is the heat flow rate. Heat flow. Q equal to, what is this one? If we'll take LCM, here you see the LCM will take, directly we'll write. So first you see here, R1, R2 LCM. So R2 minus R1. Here what we can write? R2 minus R1. So write one more steps you write. That will be better. So what we'll write here? Q R2 minus R1 by R1 R2, because this formula is little big, so remembering also tough, but already this formula will be there in the data book, so no problem, but you should understand here. So what is here? 4 pi k T1 minus T2. Now we'll write the final formula, what will be the curve Q. So what is the Q for one hollow sphere? This you write here, overall temperature T1 minus T2, because only one is there, one hollow sphere. So T1 minus T2 overall temperature, divide by, just the space not there now, I'll write it little small. So here Q equal to T1 minus T2 divide by, this will come, this and what will come? R2 minus R1 into, this also you bring here, 4 pi k R1 R2. What is this one? This is the thermal resistance. So we can write here overall temperature difference T1 minus T2 by thermal, R thermal, total thermal. So this is the heat flow rate now we got. This is the heat, where R thermal equal to, see here T1 minus T2 divided by R2 minus R1 4 pi k R1 R2. This is the thermal resistance, where R thermal equal to, this for one block. Now similarly, if we'll do now composite block, so what we'll do? We'll add only, we'll get the answer. So this you have to understand. So here thermal resistance L by Ka, here thermal resistance ln R2 by R1 2 pi KL, here thermal resistance R2 minus R1 by 4 pi K R1 R2. These three things you have to remember. So now we'll go the composite wall. So, okay, so now we'll derive the composite wall. What is the formula? Directly I'll write the formula now. Now see here, if Q will be there, this also already here, this I wrote, now leave it this part. Now I'll write what is the heat flow rate for Q is equal to. So here you see, if inner film will be there, that means convection part, and outer also cold fluid. This is a hot fluid. This will be, if you write here, a hot fluid. This is cold fluid. Once hot fluid, cold fluid is there, that means conduction and convection both will be there. So what is the conduction's heat transfer here? Already you know conduction is nothing but HA dt. So HA dt. So A will be what is here? 2 pi 4 pi r square. For square what will be there? 4 pi r square. So what will be the here the thermal resistance for this? So directly I will write here thermal resistance for this. First you write this formula for total. What is the formula here will come? So you see here 4 pi will take out overall temperature T hot fluid THF minus TCF cold fluid by overall thermal resistance R1 R for hot fluid, R1 R2 and R4. So we will see first what is the thermal resistance for this, 1 by HF R1 square, 1 by HF R1 square for convection. Then similar here, what is this one? R2 minus R1 4 pi already there. Then what will be there? I taken Ka. So thermal conductance Ka. Then R1 into R2. 4 pi I taken here only. Okay, plus second B. Now what is? R3 minus R2 divided by Kb R2 R3. So what will write? R2 R3. Then last one what is? 1 by HCF, heat transfer coefficient for the cold fluid, and R3 square. This is the total thermal resistance. This is the heat flow for the composite hollow sphere, where this convection, two conductions. Now we'll write where first block, that means convection part. Convection parts, what we can write here? So write here H hot fluid, and we'll write 4 pi R1 square. What is this one? THF minus T1. If you're writing, what will be the thermal resistance? See here. THF minus T1, overall temperature difference. Then next what will come? 1 by, if you will take here 4 pi, because 4 pi I am taking everywhere. So what will be the thermal resistance here? Hot fluid, HF, heat transfer coefficient for the hot fluid, and R1 square. So this only you wrote. Now see here, HF R1 square. If we'll go the last one, so what will write here? T3 minus TCF. T3 minus TCF. HCF R3 square for these. Conductions, what will write? This only. R2 minus R1, then R3 minus R1. So this is nothing but thermal resistance for hot fluid. Hot fluid, you write thermal resistance for RA, you write this. This you write RA. This is you write R1. This you write RA dharna RA. RB. This is you write RB. So nothing but what is formula for this? 4 pi into total thermal resistance by RA plus R capital A, R capital B, RB. So this I wrote for your understanding for one part. One part. Suppose this also na, okay, I will write at least for your understanding. So see how this coming. First one. Second one what will come? Second one will come. So you see the second one will come 4 pi temperature. Temperature will come T. Hot fluid, no, this is HF. So temperature will come T1. Temperature will come T1 minus T2. T1 minus T2. Then what will come here? 4 pi you keep it here. So it will come here R2 minus R1 by Ka, thermal conductivity R1, R2 for second. Third what will come? 4 pi T2 minus T3. Then what will come here? R3 minus R2. Here will come Kb, R2, R3. Last one what will come? Only see this here. HCF will come. So what will come? 4 pi T3 minus TCF divided by what will come? HCF into R3 square. R3 square. So this is thermal resistance for first one. This is thermal resistance for here. This is the thermal resistance for first one. This is thermal resistance for second one. This is thermal resistance for third one. This is thermal resistance for this part only. 1 by this here na. The wrote here, not space not there na. Again I will write somewhere. So thermal resistance for fourth one I am writing here only. What is fourth one? 4 pi T3 minus TCF divided by 1 by H cold fluid R3 square. So this is the thermal resistance for fourth one. So that only we wrote. So what you have to remember? Single thermal resistance, what is the convection, what is the conduction. If you remember, you can find out, you can write all the formula. Once you wrote the formula, suppose problem they given all the value you mention in the diagram and only substitute the value, you will get the answers. Okay. So next video what we'll do, we'll take one problem based on this and we'll solve. So this the formula analysis will be the very important for this. Okay. Okay students, thank you. Subscribe the channel and go through the from beginning to end these derivations. Okay. Thank you.